To another session of past paper discussion. Today we are going to discuss October number 2020, the second variant 62. Let's move on to the first question. On average, 1 in 50,000 people have a certain gene. Use a suitable approximating distribution to find the probability that more than 2 people in a random sample of 150,000 have the gene. So we know that here the given distribution is a binomial distribution of a random sample of 150,000 with a probability of 1 over 50,000. So obviously, suitable approximating distribution. So we have to approximate this to a Poisson distribution with the parameter lambda. Your lambda is n times p. Hence it becomes 3. Now, what is the reason? N is greater than 50. And NP is equal to 3, which is less than 5. So this condition will help you to use Poisson distribution. Now, as we move on to the question, x finding the probability of x greater than 2 will give you 1 minus probability of 0 plus probability of 1 plus probability of 2. That will give you e to the power of minus 3 times 1 plus 3 plus 3 to the power of 2 over 2 factorial, which will give you an answer of 0.577 corrected to 3 SF. That's the first question. Moving on to the second. A 6-sided die has faces marked 1, 2, 3, 4, 5, and 6. When the die is thrown 300 times, it shows a 6 on 56 throws. Calculate an approximate 96% confidence interval for the probability that the die shows a 6 on 1 throw. So here we have to think about a 96% confidence interval. So the unshaded region is your confidence interval. Now we have been given a proportion which shows that 56 times we get a 6 in 300 throws. So that's a proportion. And we move on to find out the z value of this 96%. So the remaining 2% is here, 2% is here. So z is same as pi inverse of 0.98. That will give you a value plus or minus 2.054. Then we move on to the formula. P plus or minus z times root of PQ over N, which gives you 56 over 300 plus or minus 2.054 under the root 56 over 300 times 244 over 300, the whole divided by 300. Which will give you a value 0.140 to 0.233. Both are rounded to 2s. Okay, so that gives you the confidence interval. Now, Marola claims that the die is biased. Use your answer to part A to comment on this claim. Now we know that the probability of getting a 6 is 1 by 6, which is equivalent to 0.666. Now, if you look into the previous interval, which was from 0.140 to 0.233, you can see that this value 0.666 falls in between this range, between the interval. So we can come to a conclusion that Maraula's claim is to be rejected. So reject the claim of Maraula. Why? As 1/6 falls in the above interval. So we can write, also we can write in place of this, you can write no evidence to claim that die is biased. So reject Maraula's claim. So any of these options would be fine. Moving on to number 3, you've been given a graph. The graph represents a probability density function, and the values are given, and on the y-axis, the y-intercept C is to be found out using our PDF function. Let's go to show that C is 2/3. So as we know that it's a PDF function, the whole area is going to be 1. And since this shaded region is a right-angled triangle, we can use the formula of a right-angled triangle. Half 3 times C is 1, and C will be 2/4. So that's the first part. Now probability of x greater than 2, which carries only 2 marks. So we can use any concept of finding out the area shaded in red. So this is the area that we need to find out. Probability of x greater than 2. So let's imagine that the given triangle from 0 to 3, and that is C, and the smaller triangle which we need to find out, which starts from 2 and goes up to 3. The area of this rectangle, so triangle, is 1. This is the area that we need to find out. So this happens to be similar triangles, and as we know, the ratio of their areas will be the ratio square of the ratio of their sides. So let's move on to do that. So area of triangle, let's say this triangle is A, this triangle is B. So area of triangle A over area of triangle B is equal to 3/1 the whole square. So area of triangle is given 1 by area of B is equal to 9. So we are finding area of B, which will be 1/9. So that is probability of x greater than 2 is 1/9. So you can use this concept, or you can use directly the line function. You can find out the function y equals mx plus c and then get back to this answer, but know that it carries only 2 marks. So try to find out an easy solution to that. Now coming on to expectation of x, we know that expectation of x equals integral x fx dx between the limit minus infinity to positive infinity. But here we don't know the function. So to find the function of the equation of the line, you can use y equals mx plus c. So to find the function, you can use y equals mx plus c. So using the formula, 2-point formula, you can find out the gradient, which is minus 2 by 9. So y equals minus 2 by 9 x plus 2 by 3. So expectation of x will be integral 0 to 3 x times minus 2 by 9x plus 2 by 3 dx is equal to integral 0 to 3 multiplying x inside minus 2 by 9x squared plus 2 by 3x dx, which is equal to, after integrating, you get minus 2 by 9 times x cubed by 3 plus 2 by 3 times x squared by 2. Between the limit 1 to 0 to 3, which will give you, by substituting the values, you'll get minus 2 over 9 times 3 cubed over 3 plus 2 over 3 times 3 squared over 2 minus, as it is 0, and both terms contains x, so this will become 0, which will be, you can cancel this off. 3 cubed is 27, so you get a 3 there. This 3 also gets cancelled. Here you have 3 remaining, 2 can be cancelled. So what you have is minus 2 plus 3, which is equal to 1. So expectation of x equals 1. Moving on to the next question, number 4. The area x centimeter square of petals of a certain kind of flower have mean mu centimeters square. In the past, has been found that mu is 8.9. Following a change in the climate, a botanist claims that the mean is no longer 8.9. The area of random sample of 200 petals from this kind of flower are measured, and the results are summarized. Sigma x is given to be 1850, and the sigma x squared is given to be 17,850. Test the botanist claim at 2.5% significance level. So let's see in this, what are the data that is missing. To test, we need a test stat, which is x bar, and we also need a variance, that is s squared. As the sample is given, so we need to find out the estimated population variance. So sample mean will be sigma x by n, which is 1850 over 200, which is 9.25. Whereas s square is 1 by 199 times 17850 minus 1850 squared over 200. That will give you 3.7060 the zone, which is approximately 3.71. So we got both these values. Now let's go for testing. It has been given that in the past, mu was the population mean, mu was 8.9. Now, the claim is that is no longer, the mu is no longer 8.9, and hence it's a two-tailed test. The significance level is given to be 2.5%. So your graph will be looking like this. This is your rejection region, the critical region, and it is being spread over on both sides. So hence this will be 2.5 by 2%, and this will be 2.5 by 2%, since it can be divided by 2. So significance z, the z value will be the z value will be phi inverse 0.9875, which is equal to plus or minus 2.24. So why is 0.9875? Because the z value corresponds to the whole area to the left. So what is in between is 97.5 plus this one, so which is 0.9875. Now your test stat x bar is given to be 9.25. So converting this x bar to z, this will be 9.25 minus 8.9 over the variance you have already found out, 3.7060, etc., by whole divided by 200, which is equal to 2.57 to 3SF. Now this 2.57 is greater than 2.24. So this value is 2.24 on a standard normal distribution, and 2.57 will fall to the right of 2.24, which means that it is falling in the rejection region, and hence we can write that there is enough evidence that the value of mu has changed. So that's it in testing. So before testing, you make sure that all the data is being given to you. The data was missing was x bar and the variance. We found that. We established the hypothesis. We drew the figure and we found out what is the z value in standard normal distribution. And we found it's 2.24. Then we converted our test stat 9.25 as well to the z value. And we found it is 2.57, and we found that 2.57 is following the rejection region and hence reject the null hypothesis. Moving on to the next question, number 5. Customers arrive at a shop at a constant average rate of 2.3 per minute. State another condition for the number of customers arriving per minute to have a Poisson distribution. So we know that Poisson distribution must happen. So arrival should be independent That is another condition. So here you can see that they arrive independently, or even you can write singly or randomly. Anything can be written over there. It is now given that the number of customers arriving per minute has a distribution of 2.3. Find the probability that exactly 3. So X is a Poisson distribution with 2.3. We have to find out the probability that exactly 3 in 1 minute period, which is equal to e to the power of minus 2.3 times 2.3 to the power of 3 by 3 factorial, which will give you an answer 0.203 corrected to 3SF. Find the probability that more than 3 customers arrive during a 2-minute period. So 2.3 is for 1 minute. So 4.6 will be for 2 minutes. Probability that X greater than 3, which gives you 1 minus probability of 0, 1, 2, and 3, which is equal to 1 minus e to the power of minus 4.6 times 1 plus 4.6 plus 4.6 squared over 2 factorial plus 4.6 cubed over 3 factorial, which will give you an answer 0.674. Moving on to the next part. 5 1-minute periods are chosen at random. Find the probability that no customers arrive during exactly 2 of these 5 periods. So probability of finding that no customers arrive. Exactly 2 of these 5 periods. So this is basically a binomial distribution where in 5, exactly 2 is happening. But what's the probability that is to be written over here? The probability is that no customers, or probability that no customers arrive. So you need to find out the probability no arrival of customers. So for that, we need to look into our average. Customers arriving is 2.3 per minute. So what is the probability that no customers arrive during these occasions? So probability of no customers arriving is that probability that X equal to 0, which means e to the power of minus 2.3, which is 0.10026, etc. So this is the probability that is to be used over here. So what will be the probability that X equals 2 when there's a 5 trials going on? So which means it is 5C2 times the probability which is given over here, this probability to the power of 2 times Q to the power of 3, 5 minus 2. That will give you 0.0732. 0.073. Both are acceptable. So here P is 0.10026. Q is 1 minus P. All right, let's move on to the next question, number 6. A biscuit manufacturer claims that on average 1 in 3 packets of biscuits contain a prize offer. jury suspects that the proportion of packets containing the prize offer is less than 1 in 3. In order to test the manufacturer's claim, he buys 20 randomly selected packets. He finds that exactly 2 of these packets contain the prize offer. Carry out the test at 10% significance level. So the claim is that probability is the offer is that it contains 1 in the prize offer contains 1 in 3 packets. Now the alternate claim H1 is that it is less than 1 by 3. So the observed value, that is true in when he selected or when he buys 20 selected packets. So let's say that reject H0 if probability of X less than or equal to 2 is less than 0.1. So the observed value, if the probability less than the observed value, if it is less than the significance level, we can reject it. So let's find out probability of X less than or equal to 2, which is equal to probability of 0 plus probability of 1 plus probability of 2. As you know that this is a binomial distribution with 20 and the probability is 1/3. So which is equal to 20C0 times 1/3 to the power of 0, 2/3 to the power of 20 plus 20C1 times 1/3 to the power of 1, 2/3 to the power of 19 plus 20C2 times 1/3 to the power of 2 times 2/3 to the power of 18 gives you 0.0176. That happens to be less than 0.1, which means that we have to reject H0. There is enough evidence to support jury's suspicion that the prize offer is less than 1 in 3. It's up to you. You can write down the conclusion as per your understanding. Moving on to B. Maria suspects that the proportion of packets containing the prize is less than 1 in 3. She also carries out a significance test at 10% level using 20 randomly selected packets. She will reject the manufacturer's claim if she finds that there are 3 or fewer packets containing the prize offer. Find the probability of type 2 error in Maria's test if the proportion of packets containing the prize offer is actually 1/7. So we can come to already there's a conclusion given there that she will reject. So we can say that the rejection region is given to be X less than or equal to 3 or fewer than 3. So we are asked to find out probability of type 2. We know that probability of type 2 is probability of acceptance region given a new probability 1/7, which is equal to probability of X greater than or equal to sorry, greater than 3. Greater than 3 with a new probability of 1/7. So again, it's a binomial distribution with 20 and 1/7 as the probability. So probability of x greater than 3 is 1 minus probability of 0, 1, 2, 3, which is equal to 1 minus 20 C0, 1/7 to the power of 0 times a 6/7 to the power of 20 plus and goes on. That will give you an answer of 0.318 corrected to the 3 SF. So that's the type 2 error. Explain what is meant by type 2 error in this context. So again, you can write including that the price offer, concluding that the price offer is 1/3, where while in reality it is less than or offer is one. The price offer is 1 in 3 package, where in reality it is less than that. Okay, so that's the conclusion. So in general, we can say that what we mean by type 2 error is accepting wrong null hypothesis. So this is the general idea. So based on this idea, you can make up your own statement. All right, but moving on to question number 7. Before a certain type of book is published, is checked for errors, which are then corrected. For costing purpose, each error is classified as either minor or major. The number of minor and major errors are modeled by independent distributions given there. You also should assume that no continuity corrections are needed when using these models. A book is chosen at random. Find the probability that the number of minor errors is at least 200 more than the number of major errors. So let's write down all the given distributions down. So we can write here as minor is given to be a normal distribution with 380, 140, whereas major is following a normal distribution with 210, 80 as the variance. Now, find the probability that the number of minor errors is at least 200 more than the number of major errors. So try to put them in symbols. I will be writing it in this form, that the minor is at least 200 more than the major, which can be written as minor minus the major is greater than or equal to 200. So this is what I have to find out at the end. Now I need to know what is the distribution of the difference of minor and major, minor minus major, normal distribution with their mean and variance. So for that, I need to find out the expectation of m minus m, which is equal to 380 minus 210, which will give you 170. Similarly, variance of will give you 140 plus 80 because variance cannot be subtracted, which will be 220. Coming on to the probability greater than or equal to 200 is equal to 1 minus pi of 200 minus 170 over the root of the variance. This will give you 1 minus pi of 2.023, which is approximately 0.0216, rounded to 2. So that's the probability. Moving on to the next part. The cost of correcting a minor error and a major error are 20 cents and 50 cents respectively. Find the probability that total cost of correcting the error in the book is less than $190. So the total cost is 24 minor plus 54 major. And we have to find out that the total cost is less than $190, which is 190 times 100 to make it into cents. All right. So this is what we need to find out. So we need to find out the distribution for n. So expectation of t is equal to 20 times the average of minor 380 plus 50 times 210, that will give you 18100. Similarly, variance of t will be 20 squared because it's a scale factor. 20 squared times 140 plus 50 squared times 80 will give you 25600. All right, so we got the mean and variance. Now coming on to the probability, that will be equal to phi of 19000 minus 18100 whole divided by the root of, this will give you phi of 1.778, which is equal to 0.962. So hence the probability of t being less than $190. So hence we have come to the conclusion of the solving of this paper, October November 2020, the second variant. Thank you.